This is day 13, lesson 9, inequality word problems. You've been working with inequalities, which are mathematical statements that compares relative values to two quantities. In these problems, you're also going to be introduced to using some other vocabulary words. Gross profit is money that you earn before you have any deductions. For example, if you're working a job, minimum wage, let's say, is $7.25 an hour. But when you get your paycheck and you multiply it, you find out that you don't get a whole $7.25 for every hour. You have deductions, like for taxes. Also, when you're trying to sell items, it costs you money to make the item. So the money that you charge, or the price that you charge a customer, is your gross profit. But cost is the money it takes for you to make the item. So cost is something that you would subtract from your gross profit to get what's called your net profit, or the money that you earn after deductions. Or after, you can replace that word deductions with costs. And other problems we're going to be looking at are averages. And just a refresher on what the word average means. It's the sum of numbers. Oops, that's supposed to be an N. I'm just going to shorthand this, divided by the quantity, or the number of numbers. Okay, sum of numbers divided by the quantity of numbers. For example, if I had 3, 5, and 7, if I wanted to find the average of 3, 5, and 7, I would add 3, 5, and 7 and divide it by 3 because I have 3 numbers. That's the quantity. So how do we use inequalities? Well, let's think about this example. Megan takes her little brother on a roller coaster at the state fair. For safety reasons, the height requirement is 4 feet for the ride. So mathematically, we can write h for height is greater than or equal to 4, indicating that there is a range of heights that meet this requirement. So there's more than one height that's allowed to ride the ride. To simplify it, we just write the h is greater than or equal to 4. So anything greater than or equal to 4 would be considered a solution. We use inequalities more than equations in our real life. How do you check an inequality? You simply will choose any value to see if it's true. So with inequality, if we have a set of numbers as our solution, it's unreasonable to expect that every possible number in your to check every single number. But you must check at least one value in the range to confirm to make sure the inequality is true. For example, if I wanted to know in the previous example, well, if somebody is 5 feet tall, is that true? Let's find out. We can replace the h with 5. Is that greater than or equal to 4? Yes, that's true. But let's say you got a solution of h is equal to 2. Is 2 greater than or equal to 4? No, that's false. All right. So when do I use the less than or equal to sign or the greater than or equal to sign in word problems? The less than or at most symbol, less than or equal to or at most symbol, is used when there is a maximum value you must not exceed. In the problems of this type, you're often buying an item or service, but you have a maximum amount of money that you can spend. To help you remember this symbol, and it's used for maximum, think of Rack's Maximum. Rack's, the restaurant you buy hamburgers at. Look at my symbol. Do you see which direction it looks like a mouth chomping that hamburger or eating the hamburger to help you Rack's Maximum? So that's the inequality goes, the inequality goes this direction, like that. In word problems where there's a maximum, and sometimes you'll get an answer that ends in a fraction or a decimal. Most of the time you cannot buy part of an item or a service. For example, if you went to Rack's, you can't just buy half of a hamburger. But if your money will only allow you to buy, let's say you get an answer of 3.5 as your answer for the amount of hamburgers you could buy, for example. You can't buy 3.5 hamburgers, but your money will only allow you to buy at most 3.5. Therefore, you will always round your answer down to the nearest whole item. So the most you can buy is 3 hamburgers. So always round down when you're using maximum. The standard format for these problems, and it's the same scenario usually all the time, is a price times your variable plus any money you've already spent. Now, if you have a coupon or a discount, then that would be a subtraction of the money. So an alternative you could have is minus discounts. But most problems you'll find on the ECA, it talks about money that you've already spent. Is less than or equal to the maximum amount of money you have to spend. The greater than or equal to sign, or at least symbol, is used when there's a minimum value you must make in order to pay for something, like a lease. Sounds like leased, right? Lease and lease to help you remember this symbol. Or rent, and that's usually the word that's used in the story problem is rent. To help you remember, minimum goes with rent. Think of condominium has the word min in it, like you're paying your rent for your condo. Other problems like this, or types of problems you could have like this, is that you're working to pay for that rent. If you're working, then you would just, whatever your rate is for every hour that you work, you would multiply that to your variable. You would then add money that you've already spent. You want it to be greater than or equal to the amount of money that you need, or the minimum needed, like the rent that you need to pay for your apartment. Other times you'll be selling products. If you're selling a product, then you'll have your selling price times your variable minus, there's that word cost, that it takes to make it times your variable, is greater than or equal to, again, that minimum amount of money that you need to pay for your rent, your booth space, whatever the story problem might be. A third type of problem you could have is when they're talking about percentages, like in grades, and it's often an average. So the total points that you've earned plus maybe that one less test, so that's your variable. So it's total points you've earned plus X divided by the total points possible is greater than or equal to the minimum needed, usually the minimum percentage, whatever it takes to pass. So those are the 3 standard formats for the 3 types of scenarios of at least problems you could have. Just like before with the Rack's Maximum problems, you can buy a partial item. Same thing with when you're working, you cannot pay less than your rent, not even 2 cents less than your rent. So if you get a decimal or a fraction for your answer, you'll need to make sure you always round up. You'll need to work that next hour or that full hour in order to pay your rent, so always round up. on those problems. Turn to the next page and let's see if we can write the translation for some phrases to make sure you use the right symbol, the at least or the at most symbol. Important words is at least. This is something you might see in a problem. For example, Kira is at least 21 years old. So Kira's age, another way of saying that is Kira's age is greater than or equal to 21. So A for maybe her age is greater than or equal to 21. So is the at least. This is like a condominium. There's a minimum value. We're not eating our minimum. We only eat at racks, right? Our maximum. So look at the direction of your inequality and make sure it's not eating the number. At most 5 students drop the course. So no more than 5 students drop the course. Another way to say that is 5 or fewer students drop the course. All this is just like going to racks. The most you can spend or the most students at most is always the less than or equal to sign. So students are less than or equal to 5. That's how you would write that statement. The next example, cannot exceed. Well, what does that sound like? Does that sound like a maximum or a minimum? There must be a maximum. Earnings cannot exceed $1,200, so that's the max. So which way would it go? You need to eat your max, right? Earnings is less than or equal to 1,200. Must exceed means there is a minimum value. The speed must exceed 15 miles per hour. The 15 miles per hour is the minimum, like condominium. So don't eat it. Is less than. Well, we know what the less than symbol looks like. Oops, it just says less than. It doesn't say less than or equal to. Less than. Spot's weight is less than 50 pounds. Does he weigh 50 pounds or can he weigh 50 pounds? No. So Spot is less than 50. You may have used a different variable than S for Spot because what you're actually talking about is the weight. So the weight is less than 50. W is less than 50. And the next example is more than or is greater than. Boston is more than 200 miles away. So B is greater than 200. And then finally, in between. And this one's tricky. If we want to say something is in between two numbers, there is both a maximum and a minimum value. The way you would show that is you write your minimum value first on one side, your maximum on the other, and your variable goes in between. So the film is between, so we'll go F for film. It's in between, so the film is less than 100, but it's greater than 90. When you're showing it in between, you will have two inequality symbols with your variable in the middle. Your inequality symbol should always point to the left if you have your minimum value on the left-hand side and your maximum value on the other. To help you remember this, you can think of that song where it says, to the left, to the left. Okay, so if you're talking about between, always make sure your two inequality symbols are pointing to the left. And you had compound inequalities before. That's what that is. It's that compound inequality. Alright, we're going to practice translating some of these verbal phrases into an inequality statement and then solving it. So the first question, the product of t and 5 is at most -6. Let's look for those inequality words here. What is the inequality word here? Circle the keywords. Let's see, is at most. That is our key word for our inequality statement. So at most, like at most we have to spend, well that's at rack's maximum, right? We got to eat our most number. At most what? -6. That's our maximum value. So standard form says you have your inequality symbol and then your maximum value. The product is a key word. What does product mean? Hopefully you said multiply. The product of t and 5. Would we write t times 5 or t5, or would we write 5t? Should write 5t to show multiplication. Right. This problem doesn't have any constants in it for us to add to it. Now that we have our inequality statement, we need to solve it. To get that t all by itself, you would divide by 5. Sorry, that didn't come out. Divide by 5. So t is less than or equal to -6/5, which doesn't reduce any. Right? And then you could ask yourself, is that a reasonable answer? Well, that's kind of funny to say. The product of t is so -6/5. Well, we could check it. -6/5. That's our t value. Times 5. Is that less than or equal to -6? Well, the 5's cancel out. Is -6 less than or equal to -6? It's equal to, so yes, that's true. We checked it. That's not usually how you're going to check your story problems. Let's look at another example and I'll show you how you can check easier. In focus question 2A, these are inequalities with cost and revenue, or you're selling an item but it costs you something to make it. So step 1, read the word problem, circle the keywords in the problem, underline the number of words and the variables, the unknown problem. So let's first just read through the problem. Shelby sells t-shirts. It costs Shelby $6.50 to buy each t-shirt. She also pays $150 each month in rent, or to rent equipment and to print the t-shirt. Shelby sells the t-shirt for $12. They want you to write an inequality that can be used to determine the number of t-shirts Shelby must sell each month in order to make a profit for the month. So we have a lot of things going on here, but if you can identify your selling price and your cost, let's find those two items first. Our selling price is our gross, so gross is where you would put your, sorry, let me get my pen. Gross is, what are we selling it for? Well, let's see. This says she's buying each t-shirt for $6.50. It looks like she's putting a design on it. So that $6.50 that she buys each t-shirt for, that's actually her cost. She has to buy the shirts before she can sell them. So that $6.50 goes here, actually. $6.50, but that's for every shirt. They said to use the letter T for t-shirts. So that's where our cost is $6 for every t-shirt. We still haven't got to what she's sold them for yet. She pays $150 each month to rent equipment. Ding, 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 keyword there. So there's that rent. What type of problems did we talk about where we're paying rent, I told you before? At lease, like condominium lease. So this is the greater than or equal to sign. We must have a minimum value we must make. And that minimum value to pay that rent is the $150. And then the last part of the problem, she says she sells it for $12. For each t-shirt, that's $12. So 12T. So that's the equation that we need. The selling or gross price minus the cost is greater than or equal to 150 in order to have enough money to pay that rent. Next step is we need to find your net profit. The net profit is when you're combining these two terms together, the 12T minus the 650T, to find out how much do you actually make per t-shirt. So $12 minus 650, what is that, $5.50? So she actually nets $5.50, or actually makes $5.50 for every t-shirt she sells. Is still greater than or equal to the 150. And then finally, to find out exactly how many t-shirts she must sell, we have to divide by the $5.50. Divide by $5.50. So T is greater than or equal to, if you plug it in your calculator, you get 27.272727. It keeps repeating. Now, can we sell 0.27 of a t-shirt? No. So again, what do? Do we round up or round down? Remember condominium, we need to make a minimum value. So these are the problems that you always need to round up, regardless of the other rounding rules. Just because that's a 0.2, normally rounding you would round it off to 0 and just be 27, but we will always round up. So the actual number of t-shirts she must sell has to be greater than or equal to 28 t-shirts. So when you have the at least, you always round up. Since students always have trouble with these types of problems, I did give you a second example of the same type of problem. So this one will be set up the same way. This is another inequality with cost and revenue. Again, remember our standard format. How much are you selling an item for? Minus the cost. Oops, not cost, cost. You're always trying to go greater than or equal to some minimum value. So let's read this story problem. Christina sells fiction books. So that's a good indication that this is this type of problem. If you're selling an item, it's usually this type. It cost her $2.25 to print each book. There's our cost. Remember, it's each book. So $2.25 for each book. I'm assuming, yeah, they would do want you to use B as your variable. Sorry about my dog barking. She pays $150 each month to rent. Ding, ding, ding. So that must be our minimum value. We need to be able to pay our rent. $150 to print the books. She sells each book for $11. It did say each book, so you need it times the variable. So the sell minus first. There's our equation. To find out how many books she must sell, we need to find our net profit. So combine those two terms together. 11 minus 225 is $8 and, oops, I just lost my number. 75 cents per book. Still, we want to go greater than or equal to $150, the amount of our rent. To find out how many books we need to sell, or she needs to sell, you divide by 875. Divide by 875. Go ahead and use calculator on these. So the number of books should be greater than or equal to, let's divide. You're going to get like 17.14285 to 1428. It's going to keep on repeating now. And again, we have a minimum value, so we always have to round out. So the number of books she must sell is greater than or equal to 18 books. Okay? Another type of at least problem is our averages. So here they have high temperature for the last 2 days were 102 and 105 degrees. What must the high temperature be today in order for the average temperature for all 3-day periods to be no more than 100 degrees? So no more than, now this time they're using no more than. I say usually it's an at least problem, but in this case they're making the 100 degrees to be a minimum because it says no more than. So we want to stay under 100 degrees. It didn't say equal to, so let's just keep the less than sign. So we want to stay less than 100 degrees. So our averages is you have the 102 plus the 105 plus our unknown third day's temperature. Maybe we can use a T there. So we want our temperature for our third day. Average is the sum of the numbers divided by the total number of numbers. So in this case, there's 3 days. That's our quantity. There's our equation. To solve it, we need to combine some like terms here. So let's combine these two terms together. 102 and 105 is 207 plus T over 3 is less than 100. I can't combine anything more there on that one, but I do notice I have, let me rewrite that for just a second. Okay, that looks a little bit better. What I've created now is a complex fraction. So what do we do with complex fractions? Hopefully you said you need to cross multiply. So we multiply that 3 times the 100. 207 plus T is less than 100 times 3 is 300. Sorry. Next we have that 207 that's being added to T. It's not directly beside it. It's being added to it. So to get it to the other side, you'd have to subtract the 207. So T is less than, looks like 300 minus 207 is, what, 93. Okay, so our temperature has to be less than 93 degrees in order to have that average temperature of less than 100 degrees. Let's try some guided practice problems. I want you to attempt each problem on your own, push pause, and then push play to check your work. Okay, the first one, let's see how you did. Jalen pays a $5 monthly fee and 5 cents per minute for his long-distance phone calls. He does not want to spend more than $12, so it looks like he's buying a service. And he doesn't want to spend more than the $12 on long-distance charges. So he needs to stay less than or equal to $12. This is the rack's maximum. Alright. That $5 monthly fee, remember we talked about flat fees? You would add that flat fee to your minutes, which there's a rate per minute. There's that keyword per. So 0.05 per minute. Here's our standard format. Your coefficient is 0.05 because it's the per word, plus our flat fee less than or equal to 12. So all I want you to do on these is to write the inequality statement. I don't need you to go in and solve it on these ones. The next one, Laura makes $850 per hour. There's that per. $850 per hour. She's working at a convenience store. She gets a bonus of $25 this week, so that's a flat bonus. Didn't matter how many hours she worked, she got that bonus of 25. How many hours must she work to make at least $195? So there's your inequality. The third example, small algebra class of 5 students was told they would receive a pizza party if their class average was 42%. That's supposed to be or higher on the next test. So 92% is our minimum value. Condominium, so we want to stay, oops, I wrote it the wrong way. We want to be greater than or equal to 92%. We have several scores here, 86, 91, 98, and 85. But we need to know what the 5th student should get. So let's add up all these scores right here, plus our 5th student. So plus x, that one score that we don't know, and divide it by the total of our 5 students altogether. Add up the 86, 91, 98, and 85, and that's the number that you will add to your x value. I got 360 for that total. So 360, those 4 scores plus the 5th score divided by a total of 5 scores is greater than or equal to 92. That's the inequality that you would have. The last one, Jaquela took her daughter to Ben and Arish and gave her $20 to spend. That's the most she can spend. That's like a rack's maximum. So at most she can spend is $20. Each game costs 75 cents. So there's that word each. 0.75 for each game. She used $6.50, so that's money that she's already spent. She can't change that, so you just add to that the $6.50. And there's your inequality statement. Now it's your turn. Do the group practices on the next 2 pages and then check your work on the next file.